Welcome to this module of Professor Messer's free CompTIA Network Plus certification training course, the online training course with copper kettles sitting side by each. I'm James Messer, and in this module we're going to talk about IP addressing technologies. This comes from our Network Plus exam N10-004, section 1.4, where we need to know these types of technologies. We need to know more about supernetting. We need to know what the difference is between a public IP address and a private IP address. And then we're going to talk about natting, snatting, denatting, padding. There's a lot of addings in there. We're going to talk all about those. And then we'll finally talk about DHCP and some automatic addressing technologies that you need to know about. We'll start our conversation with supernetting. Now, we've talked in the past few videos about subnetting, where we take a single subnet and we split it up into smaller chunks. Supernetting is really the opposite of that. We take a single network address and we make it bigger. Now, the reason you would do that generally is because you need to point to an aggregate route. Let's say on your network that you have a lot of different IP addresses, and they happen to be an IP address range that goes all the way from 192.168.1.0, and you've got networks that run all the way through to 192.168.255.0. So there's a lot of networks that you happen to have in your environment. Now, it would be very easy in your router to say, if you need to go to 1.0, go here. If you need to go to 2.0, also go there. If you need to go to 3.0, also go there, and have a lot of different entries in your router that points where the packet should be going. Or you can supernet, and you could say to the router, if you need to go to anything that's 192.168 with a 16-bit subnet, which means you're going to anything in that range, just go out that one link. So you've taken over 250 routing lines in a routing table and you shrunk them down to one. That makes your routers much more efficient in the way that they operate. And as you move up the scale in your routing, you'll find that you do a lot of supernetting, or you aggregate routes in a way where you're using some of these supernetting techniques to be able to consolidate networks into one single line. Many networks these days are using private addresses to their IP address range. If you're on a local network at a SOHO, you're in your house with a wireless router, or you're connected to a cable modem through a router, you probably inside of your house are using a private addressing scheme. The reason we came up with a private addressing scheme, well, there are a couple of reasons. One was to minimize the impact of everybody's house being on the internet. I don't have to use what's called a public or a routable IP address that is publicly accessible from the rest of the world. I have a private address, and one of the challenges, of course, is if I have a private address that's private to my network, and that IP address cannot talk on the internet. We'll talk in a moment how we get around that particular problem. There is an RFC that is 1918 that talks about private addresses, and it says that these IP address ranges cannot talk on the internet. They're non-routable out on the internet. They're only used behind a firewall, behind a router on a local network, and nobody else can use that as long as you are inside of your network. So IP address ranges would be this 10-dot address all the way through with this what we call a single class A, which means that we're using this 8 bits of subnet as the CIDR block or the subnet mask for that 10-dot address. Also, this range of 172.16.0.0 through 172.31.255.255, all of those addresses are private and cannot be routed on the internet. If you want to write it out, this is the CIDR block notation. There's the subnet mask, the traditional subnet mask notation for that network. You could also see, and this is what many of these home office routers have in them, is 192.168.0.0 through 192.168.255.255, which means it had a subnet mask of 16. All of those IP addresses are unroutable on the internet. This means I can take any set of any of these IP addresses and use them on my internal network, and I don't have to worry that I'm conflicting with anybody else in the world. The problem is, though, if I need to talk on the internet, I need to do something that allows me to communicate out there even though I'm using these private addresses. And we're going to talk about network address translation that gets us around that. But whenever you pull up and look at your IP addresses, if it matches any of those IP addresses or range of IP addresses and you're in there, it's a private address. If it's any other IP address, it is what we call the public address. So if you're asked, is 10.1.0.0 a subnet that's public or private, you need to know that that is a private IP address range. So take those three ranges, just commit them to memory. You'll be using them a lot also if you happen to get into doing a lot with networking, and the Network Plus certification exam really helps you along with that. I mentioned that if you're doing this private addressing, you still need to be able to talk on the internet. In fact, if you have a home office or you're using one of those wireless routers and you have a 192.168.0.1 IP address and you're able to use the internet, how is your private address still able to use the public internet? Well, we do that through something called network address translation. It's almost commonly referred to as natting. This NAT takes the IP address you have internally, converts it to something else, and then it's able to talk out on the internet. It really converts it to a publicly available IP address. We call this a layer 3 from the OSI layer conversion. We're converting the IP address from one thing to another. We're not really changing anything in the packet. No data really changes. Only the IP address that happens to be in there. There's different kinds of natting. There's one called a source NAT, a SNAT. The source NAT converts the source IP address to another IP address. And this is when you want to take perhaps a large number of internal IP addresses in your organization and convert them so they look like one single IP address when they talk out on the internet. So you might have 1,000 devices on your network, but you're only using one public address to communicate out on the internet. So very efficient in the way that it operates. And that's almost always what we're doing with these small home office type of routers that we use today. There's also something called destination NAT. Now, we don't do this very often in our home office. This takes a destination IP address and converts it to another IP address. This is used most often if somebody is trying to access a device that's on our internal network, but they're using our external IP address to communicate with it. So we have to somehow see that packet coming in, recognize that it's destined for our internal server, and convert it so that it can use our internal IP address numbers. That's called destination natting. Now visually, this is what it looks like. Our source network address translation means that all of these devices that are out here on our network will communicate out to the internet, but they will all look like they're coming from the 66.20.1.12 address. And it all goes out to the internet, and you probably have within your router somewhere something called a source NAT conversion table. You may not even see it, but it's in there. And it knows that if it receives any source IP address on this side of the router, just convert all those IP addresses so the source looks like they're coming from right here. And that means when something responds back, they're responding back to that single external IP address, and your router again is responsible for converting that back on the inside back to you. It's a process that takes place all the time, normal process of doing source network address translation. Now, we also talked about doing destination network address translation. That's when somebody else out on the internet needs to access a service inside of your network, and they're all going to point to a single IP address. Now, they all need to talk to a single server that happens to be on your network. Here's the web server, for instance, they're going to. And what you have to do is tell your router, if anybody is coming into 66.20.1.14 and they're using the port number associated with a web server, maybe it's port 80, that's the common port number for web services, convert that to that destination address to 192.168.3.22 and send it on its way. So that router handles really being the front man. It's really doing a firewalling, if you will, making sure that nobody can talk directly to that server. You first have to be natted, a destination network address translation, before anything can get through. So there's a step that has to take place to do the conversion to talk to the web server and then back out again. There's also a technology called PAT. This is done very often, usually with that destination translation that we were doing before. And this is how this works. It's the same process we were looking at before. We have somebody out on the internet that wants to talk to our web server right here. But what if this web server was actually providing many different web services on it? It wasn't doing just one port number. That means these devices out here on the internet could talk to 66.20.1.14 on port 80, port 81, and port 82. And each time it hit one of those ports, we did a port address translation along with our destination network address translation. We're doing really two. We're doing a destination and a port translation at the same time to 192.168.3.22. If you're going to 80, we're going to convert your port to 8080. If you're going to port 81, we're going to convert your port to 8081. And if you're doing port 82, we're going to convert you to port 8082. So your source NATing, your destination NATing, and your port address translation that's taking place is all just doing conversions. It's all taking a single number and changing it to something else. Nothing more complicated than that. Just keep track in your mind when you would use source network address translation, when you would use destination network address translation, and when your port address translation comes into play. You've probably plugged into a network with your laptop or your desktop. You've brought up your browser and you've started browsing the network, and you didn't have to do any type of IP address configuration on your machine whatsoever. That is thanks to something called Dynamic Host Configuration Protocol, or DHCP. DHCP is very common to see on the local routers that we have in our home office. Large organizations have individual servers that are dedicated for doing DHCP, and it's really just a way to automate that process of providing you with an IP address, a subnet mask, and DHCP also supports many other options in there as well. It requires that there's some type of server or service on your network to do this. If you did not have a home office router that provided this DHCP process, then it wouldn't provide you with an automatic IP address associated with this. There are two types of DHCP addresses that you can get. One is a dynamic address, which means there's a big pool, and when you connect to the network, there's a communication process that takes place between your machine and the DHCP server that says, hey, if you have something available, just give me the next one in your list. The next person who gets on your network gets the next IP address in the pool, and there's something called a lease time. After a certain number of hours, your machine has to check back in and say, hey, it's okay, I'm still in the network, can I still keep this IP address? And then your DHCP server makes a determination to say, oh sure, you can still keep that. If after that certain amount of time you never checked back in, then your DHCP server would then make that IP address available to the next person who came onto the network. So it keeps renewing these things over and over again. That's what most organizations do for their client machines that need to communicate out on the network. But what if it's a server and that IP address needs to be exactly the same all the time? You never want to have an IP address change. It would be something called a static DHCP address, and it's assigned manually inside your DHCP server. We look at the MAC address, the hardware address of your Ethernet card on your machine, and we write down your MAC address is always going to be 192.168.1.200, and we put that in your DHCP server. Every time your server now checks in and says, hi, I'm on the network now, you get the same IP address every single time. And this makes it really easy. If you move that server somewhere else, you just need to change it once in your DHCP server, and if you change 10 servers, you can do them all at the same time and change all their IP addresses simultaneously. Very easy because it's now managed out of that single DHCP server. Very easy to do. But what if you don't have a DHCP server? What if you don't have a router on your network? Well, your Windows machines use something called Automatic Private IP Addressing, APIPA. You may have seen this if you've connected to a network and you were just never able to get in touch with any DHCP server on your network. You still got an IP address. If you look at the IP addresses on your machine, you saw that it was probably an address 169.254.0.1 through 169.254.255.254. That means you could take a group of machines, plug them into the same switch with no DHCP server, and they'd still be able to talk to each other. So that's something we didn't used to have prior to this automatic private IP addressing. It's something built into Windows and the way that it operates. Many small offices might work this way that don't have a connection out to the internet because they just need to plug in. They'll get an IP address automatically by default that fits one of these. And the automatic private IP addressing process is nice enough to go out to the network and ask, is anybody using this IP address right now? Anyone? No? Okay, I'll use that one. So you can't have conflicts either. Very simple to do, very easy to do, and you may find if you're not connected to a network with a DHCP server, you're getting one of those anyway. Let's see how well we remember some of those networking technologies and addressing technologies we were working with. What is one use of using source network address translation? It's a very common use of doing NATing in this way where you're changing the source IP address. Well, one way is you can take and translate many different source addresses to a single source address. This is when you're using an internet connection, for instance. You might have thousands of devices inside of your network, and you're making them look like one single source address out there on the internet side. Now, you could individually take every single machine inside of your network and take every single device and have it change its source address individually, but in most large organizations, you're doing a many-to-one type scenario. That's just one example of how you would use source NATing. Here's another question. What's one use of destination NATing? We've looked at source. What about destination? Well, that means their traffic is really coming the other direction. There are devices or systems out on the internet that need to talk to you. And the only way they're going to get inside of your network is if you convert the external internet address into your inside address. And you use destination network address translation to do that. Now, finally, we have something here. You got an IP address on your machine, and your IP address is 169.254.0.5, but you didn't type that IP address in. How did you get that IP address? Well, it was automatically assigned to you through a process called automatic private IP addressing. You have to remember that range. It wasn't assigned by DHCP. This was the internal automatic process built into the Windows operating system. So make sure you remember that API-PA range that may come up on your Network Plus exam. That covers all of the different addressing technologies that we need to know for our Network Plus exam, our supernetting, our public versus private addresses, all the different type of network address translations we went through, and finally this automatic IP addressing through DHCP and API-PA. For many more Network Plus videos, to participate in our message boards and much more, you can visit our website, freenetworkplus.com.